Hello, students, and good morning. We are nearing the end of March already. So let's get started with our lesson for our do now. We will respond to our prompt. We'll talk about that in a minute. And today we will continue to divide those monomials. So we're going to be working with those exponents again. So we will answer the essential question of how do I apply the exponent rule when I'm dividing monomials. We'll have some more practice with that. You guys have been doing great with it. Good job. Our assignment will be, as always, to complete the do now. We have one work page with 18 problems, and we will complete our exit ticket. And you know the most important thing, showing your work to the teacher. So if you don't get finished, you can finish it for homework. And just remember, it's that extra practice that helps you prepare for quizzes and also helps to get you ready for algebra next year. So we'll get back to our exit ticket in a few minutes. But first, let's start our do now. Says sometimes people feel really, really alone, but we do have phones, we have the internet, and we have available adults at school. If you were feeling very alone, what are three things you could do immediately at the very moment that you feel loneliness? And I live alone, so sometimes I feel alone. For me, watching TV is something that I do sometimes to keep me from feeling alone. I love to read a good book and just get absorbed in that good book and then I'm not thinking about anything but whatever the plot is in the book. Another thing, I like to do games and puzzles, crosswords and Sudoku and all of that. So all of those things help me. What helps you? So you can go ahead and put that there. And if you have anything extra you want to write, you can write it right there if you need extra space. So let's get started with those monomials. Remember, when we divide with exponents, we subtract the exponents. Also remember that we do not want to have a negative exponent in the in our final answer. So we will put a negative exponent in the denominator so that it can become positive. So for review, the first one, 10 to the 15th divided by 10 to the third, will be 10 to the 15 minus 3, which would equal 10 to the 12th. 10 to the 12th, by the way, if you do have a calculator, is 1 with 12 zeros. Big number. That is actually 1 trillion. Okay, negative 3 to the fourth power divided by negative 3 to the negative third power is going to be, we have to subtract those exponents. So it's 4 minus a negative 3, which means we would add, and that equals 7. So that would be negative 3 to the 7th power. And if you used your calculator to evaluate that, that would be negative 2,187. Now, in number 3, we have an invisible exponent of 1. So let's not forget that. So we would be subtracting 1 minus 3, which would be negative 2. So that would be 8 to the negative 2 power, the power of negative 2, which we would simplify by putting that 8 to the 2 power of 2, or 8 squared in the denominator, and that way we could have a positive exponent. If you were to evaluate that, that would be 1 over 64, 1/64. Okay, number 4 is a bit of an easy one. A to the 12th minus a to the second, or divided by a to the second, is a to the 12 minus 2a to the 10th power. And that is our final answer. And number 5, we have m, and that's negative 2 minus 4, which is negative 6, n 16 minus 2, which is 14. And we will drop that m to the negative 6 into the denominator with a positive denominator of 6. And there's our final answer. For number 6, we have p, and it's 5 minus 6, which would be negative 1 as the power, q, negative 10 minus negative 2, which is negative 10 plus 2, which is negative 8. So q to the negative 8 power. Both of these go in the denominator, so we'll put a 1 for the numerator. So it'll be p to the first power, but that 1, this 1, we're going to make it an invisible 1. We don't need to put the 1 for a power of 1. But the q will have a power of positive 8. Number 7, so 63 divided by 9 is 7. And with our x, it's 18 minus 2 is 16, and that's a fully simplified answer. Number 8, 28 divided by negative 7 is negative 4. And then we have r, 4 minus 15 equals negative 11. And then it's okay to have the negative 4 in the numerator. It's this negative exponent we cannot have in the numerator. So that would be negative 4 over r to the 11th power, positive 11, as a final answer. Number 9, negative 16 divided by 8 is negative 2. And a, now remember, this is 9 minus negative 4, which is 9 plus 4, or 13. So negative 2, a to the 13th power. Number 10, we evaluate 5 over 20. So 5 divided by 5 is 1. 20 divided by 5 is 4, because 5 is a factor of both 5 and 20. So that's 1/4 p, and we've got negative 7 minus 2, which equals negative 9. So we're going to go ahead and rewrite that with a numerator of 1 and a denominator of 4p to the 9th power, positive. And that's our final answer. Now, 16 over 24. Well, 16 and 24 are both divisible by 8. 16 divided by 8 is 2, and 24 divided by 8 is 3. So for the coefficients, we have 2/3. And then we have w. Let's look at these exponents. Negative 3 minus and negative 10, okay? So that means we're adding 10 to negative 3, which equals 7. So we can also write this 2w to the 7th in the numerator with 3 in the denominator. Number 12, both 15 and 12 are divisible by 3. So we have 15 divided by 3 is 5, 12 divided by 3 is 4, and we're going to leave the improper fraction. We're not going to write 1 1/4. So we'll have 5 over 4, and with the x's, we have 2 minus 3, which is negative 1. With the y's, we have 2 minus this invisible 1, which is 1, and that 1 will then become invisible. But when we rewrite this so that we don't have that negative exponent in the middle, we'll rewrite it 5y in the numerator, 4x in the denominator, and that x to the first power, then that can now become an invisible 1. So let's move on to number 13. So now they're getting a little more complicated. We're involving other operations as well. So for number 13, I want to start with the right side and evaluate that first. So I'm just going to copy the left side, 3k to the second power times. So negative 40 divided by 5 is negative 8. And then k to the 18 divided by k to the 6 is k 18 minus 6, which is 12. Now we still have to multiply. And when we multiply the coefficients first, and then we multiply the variables. When we do that, we'll use the product rule on the exponents, which means we will add the exponents. So first, 8 times 3 is 24. It's negative 24 because it's a positive 3 divided by, multiplied by negative 8. And we have our k, 2 plus 12 is 14, and that's our final answer. Now, on this problem, number 14, we're going to start with the left side. So 30 divided by 5 is 6, and m is negative 2 minus negative 7. Well, negative 2 minus negative 7, that's our not rule, so that's going to equal 5. So 6m to the 5th power times, and then we have the rest of the problem, 7m to the negative 8th power. So now we will change our color. We're going to multiply 6 times 7, which is 42. And our m will be 5 plus negative 8, which is negative 3. And we need to put that negative 3 in the denominator. So we'll have 42 in the numerator, m to the 3rd in the denominator. And that is our final answer. So number 15, in this problem, I would take care of the numerator before the denominator. So using the same method we used in the last problem, we multiply negative 3 times negative 16, which is a positive 48. And then when we multiply the a's, we add the exponents. 7 plus 4 is 11. And so we have 48a to the 11th divided by 8a to the 6th. And 48 divided by 8 is 6. We have our a, 11 minus 6 is 5. And that's our final answer. So number 16, we're going to work with the numerator, and then we will work with the denominator. So we have 8 times 12, which is 96. And we have c, 3 plus 6 is 9. And let's change our color and go with the denominator. We have 6 times 3 is 18. And c, 7 plus 4 is 11. Now we just have to finish this up. 96 divided by 18, both of those numbers are divisible by 6. So 96 divided by 6 is 16. 18 divided by 6 is 3, and we will leave the improper fraction. And with the c terms, 9 minus 11 equals negative 2. Now we need to rewrite this without the negative exponent. So the numerator will have our 16, and our denominator will have our 3c now to this positive second power. Now, number 17, let's move the paper up a little bit. I will evaluate the denominator first before I before I divide it into the numerator using the quotient rule, which requires us to subtract exponents. So we have our numerator. I'll just copy that over, 20x to the 9th y. And then our denominator, 6 times negative 4 is negative 24. And then the x, we have an invisible 1 there and an invisible 1 here. So that would be x 1 plus 1 is 2. We're using the product rule. And then we have this y squared as well. Now, as we simplify this, we will start with the coefficients. And each of those can be divided by 4. So 20 divided by 4 is 5. And negative 24 divided by 4 is negative 6. And x to the 9th divided by x to the 7th, 9 minus 2, or x to the 2nd, excuse me, 9 minus 2 is 7. Y, invisible 1 minus 2 is negative 1. So we still need to rewrite this. So in the numerator, we will have that 5x to the 7th. And in the denominator, and that'll be, we can put our negative sign either in the numerator or denominator. I'm going to keep it in the denominator. Negative 6y, and the 1 now is an invisible 1. So there's our final answer. So number 18, let's work with the numerator first, and then we'll go to the denominator. 18 times 5 is 90. A to the 3rd times a with an invisible 1. So that would be a, 3 plus 1 is 4. And b to the negative 2 power times b to the 2nd power is going to equal negative 2 plus 2, that will be 0. So b will eventually go away because it equals 1. Well, we have to see first what's in the denominator. Let's do the denominator first and see what the case will be. So here we have an invisible 1 as a coefficient here. So 9 times 1 is 9. And we have our a term. So we add 4 and this invisible 1, which is 5. And then we have b, an invisible 1 plus 3, which is 4. Okay, not done yet. 90 divided by 9. I'm going to actually make a little more room here because I have a couple more steps. 90 divided by 9, we're working with that, is 10. Now a is going to be 4 minus 5, which will be negative 1. And b will be 0 minus 4, which will be negative 4. So both those variables are going to end up in the denominator. In the numerator, we'll have our 10. In the denominator, we'll have a to the 1st power, and that 1 becomes invisible, b to the 4th. And that's our final answer. And then number 19, I'm going to work with the numerator first. And we have subtraction here, and we have to have like terms. So we have 18 m to the 8th n to the 6th minus 12 m to the 8th n to the 6th. Well, 18, they are like terms. 18 minus 12 is 6, so it's 6 m to the 8th n to the 6th divided by, and I'll just copy this over, 3m to the 7th n to the 2nd. Now, 6 divided by 3 is 2. 8 minus 7 is 1, so we can make that'll be an invisible 1. 6 minus 2 is 4, so this will be our final answer. The the 1, the exponent of 1 on the m disappears. It's an invisible 1. And finally, number 20. Let's work with the right side first, and I predict that after we do that, we're likely to have like terms here with the R3S11, which will allow us to add them together. We add or subtract these monomials, we must have like terms. So let's start writing. The left side, we have 14r to the third s to the 11th plus, now 15 divided by 5 is 3. And then we have r negative 1 minus negative 4. Remember, negative 1 minus negative 4 is one of our not nots. So negative 1 plus 4 equals 3. So that would be r to the third power. And then we have 15 minus 4 to the 11th power. So we do have those like terms of r to the third power, s to the 11th power, and we simply just need to add the 14 plus the 3. It's a negative 14 plus 3. So negative 14 plus 3 equals negative 11. So that would be negative 11 r to the third s to the 11th as our final answer. So let's go back to our exit ticket. When dividing monomials with exponents, subtract the exponents. So it's specifically the exponent in the denominator from the exponent in the numerator. Okay, if the exponent is negative, it belongs in the denominator with a positive exponent. So if the exponent is negative, put it in the denominator with a positive exponent. And that's it for today. Good job. So many of you are working really hard. I'm super proud of how you're staying with it the whole school year. I just am very delighted that you're taking math seriously and that you're taking your education seriously and that you understand that this is all about doing what's best for you so that you can learn and grow and be ready for high school next year. So keep practicing, keep working hard, because as you do, you'll be great.